in the world of sensory biology, you need to filter out extraneous information, otherwise known as noise, and only pass the information that you want, which we would call the signal. And bandpass filters and low-pass filters and high-pass filters are the standard kinds of filters that are used both in biology and in the electronics world to reject noise and pass only the signal. And so all of your sensory systems apply some sort of filtering. The principles are the same, but the way they're implemented, of course, is different. So the idea behind a high-pass filter is that high-frequency energy is passed. So in the world of signals, most signals of interest are complex signals, and complex signals, by definition, have energy at many frequencies. We only care about some of those frequencies, and so we will use a filter to reject the frequencies that are not of interest and pass the ones that are of interest. So in the world of doing electrophysiological recording, one of the most common kinds of filtering is to get rid of the noise generated by the power distribution system in a lab, right? So all the power is distributed as 60 cycle voltage, 110 volts, 60 cycle. In Europe, it's 50 cycles, same idea. And it radiates from all the wiring and all the electric lights. And it's then intercepted by any metal object, like wiring in your amplifier and wiring in your electrode and so forth. And now you've got this large 60 cycle noise that we don't want. What we want is to record action potentials, say, but not 60 cycle noise. So we can use a filter to get rid of that. We can use various kinds of filters. We could use, for example, a high pass filter, which would pass the energy that's present in an action potential recording, and that energy is all above 500 hertz. 60 hertz is much lower in frequency, so it would be instantly rejected by that high pass filter. We could also use a notch filter. That's a kind of filter that rejects in a small, narrow region of frequencies. So we could build a filter that notches out just 60 cycles. And that's the idea. So there's lots of filters of different kinds for different purposes. But that's the basic idea.